Hey, fellow problem solvers, Colfax Math here. Today we're working on our math test success. I'm along with the journey with you so that you could be successful on any standardized math exam. Pretty much mostly the ASVAB, but also union exams as well. Today we're working on chapter 14 in a 25 chapter book. The whole goal of this book is it is free online. You could go to it in the description, mathtestsuccess.com, download it for free. And for every chapter, there's a free video so that I'm there along with you on the journey, hopefully making this review, study a little bit easier. Right now in chapter 14, we're looking at functions. Functions are a big part of any standardized math exam, very specifically both the mathematical knowledge and the arithmetic reasoning exams on the ASVAB military placement exam. The last two chapters, 13 and 12, polynomials, quadratics, those are pretty hard. This chapter is a little bit easier. So ideally download that book, have it in front of you, have that book in front of you. If you don't have that, you have to have paper and pencil out in front of you. The only way you learn how to juggle is practice. The only way you learn how to do math is practice. So you really need to be writing. That also helps get the set in your brain. And not only are you writing, but you're doing practice problems. So you want to pause the video frequently, write down your notes, pause the videos, do the problems before I do them. And then together, we're going to do better on any standardized math exam. All right, with that said, let's go ahead and get started with functions. Functions are a really big idea in mathematics. The idea of a function is usually, instead of a dependent variable, you use that notation right there. That is f of x, and it means I have gone through my equation and I have checked that it is a function. You remember the first, kindergarten to sixth grade is really all about this number line with a 0 here. You work in units, counting backwards and forwards. You break it into fractional portions, decimal portions, percents, and then you label it x as your variable, as an unknown. And then as you progress through math, you add a second axis to it. That is your y-axis. How that all plays into functions. Y is always vertical. It is always your dependent variable. X down here is always your independent variable. So rather than work with numbers on a number line, then you go to working with multiplication and division in areas, like you are over 3, up 4. That is called an ordered pair. It is always x before y. It is always over before up. I think of that as x comes before y in the alphabet. So x comes before y in your ordered pair. After you're looking at ordered pairs on this graph, you could have multiple ordered pairs and then connect those with a line to get a linear function. And we're going to talk about linear functions in here. Just want to do a little review on that first. The other way to get over here is think of it as an elevator. You got to walk over to the elevator first and then you go up. So it's always over first, up next. Almost all high school math, K-12 math, is based on this idea of really many years based on just a singular number line, adding a second number line in there to get into two-dimensional space, creating coordinates, creating shapes, planes, lines, all of that in this Cartesian coordinate system. Okay, a couple more ideas on functions. There is an input value. That is always your x. And then there is an output value, and that is your y. Domain, that word means what are the possible values of x? So these are the possible values of x. And the word range are the possible values of y. Again, the way I remember this, D comes before R in the alphabet, X comes before Y in the alphabet. Let's say a model I'm trying to figure out is how many ice creams I sell out of my store. So those are two variables, sales in dollars and ice creams sold. So dollars are going to depend on how many ice creams I sell. All right, so these are the unit number of ice creams I sell. If I sell 0 ice creams, I make $0. Let's say those ice creams cost $4 each. So I could graph this out as a T-bar, where X is how many I sell, Y is how much I make. So this is units, and this is dollars. If I sell 0, I make 0. If I sell 1, I make 4. So that's a coordinate over 1 unit, $4 up. If I sell 2, I make 8. If I sell 3, I make 12. These are all units, and the output is dollars. So if I sell 1, I make 4. If I sell 2, I make 8. If I sell 3, I make 12. I can see where this is going. If I sell 100, I make 400. That is a point on my graph. Again, X is your independent variable. It is always the horizontal axis, always your first value. Y is your dependent variable, your vertical axis, and your second value. The domain is a set of all possible values of X. So how many ice cream units could I sell? Somewhere between 0 and some number, but I'm not going to sell negative units. So the domain for this example would be X is greater than 0. The range is, well, how many dollars could I make? I don't think it's unlimited, otherwise I'd be in the ice cream business. But Y is greater than 0. I don't know, maximum movement. Maybe the maximum you could possibly process is 1 every 2 minutes, or 30 ice creams an hour, 30 times 8, 240 units per day. So the maximum, you could say maximum domain or maximum possible values in that scenario is 0 to 240. And then the output would be 0 to, what do we say, $3, $4 to 1,000 or something like that. Okay, so there we are, quick overview of functions and function notations. A lot of times, once we recognize it as a function, and the way we recognize it as a function is with something called the vertical line test. So I have that graph, whether it's ice creams or river flow, water over time, whatever it is. I do the vertical line test. If that vertical line only crosses that graph in one place, yes, it is a function. And then usually I replace that y with f of x, saying I have done that vertical line test. The reason why that vertical line test works is the definition of a function is that there is only one dependent variable, only one output for one input. So if I sell 7 ice creams, the only output is $28. That's it. There's no other possibility. So given one independent variable, there is only one corresponding dependent variable. That is what makes it a function. I could check that by drawing a vertical line. And if it only crosses in one place, then yes, it is a function. So after I've done that test, I replace my y with f of x. But y and f of x are completely interchangeable. They mean the exact same thing. The only thing is I'm saying this is a function. Y is a function of x, my independent variable. So if I had something like f of x equals 2x plus 1, it is saying find f of 3. That is saying this is my x. Take it and plug it in there. So 2 times whatever x is equal to 6 plus 1, 7. So what I am saying with this notation, I am saying when x is 3, my output, my y value is 7. What is f of 4? We'll take 4, plug it in there, 8 plus 1, and my output is 9. 1 million, 2 million plus 1, right? I don't know. Bunch of zeros, and then what do we say? 2 million, bunch of zeros and a 1. F of t plus 1, I'm actually going to say my independent variable is no longer a number. It is a function. Take that and plug it in. Well, then f of t plus 1 is going to be 2 times t plus 1 plus 1. I take whatever it is and I plug it in for x. Okay, so with all that said, let's evaluate some functions here. I got a couple of examples. Here I am saying I've checked this thing. It is a function. F of x is equal to 3x minus 5. Find f of 2. I take that 2 and I plug it right in there to get 6 minus 5 or 1. This is a linear function, meaning it has a constant rate of increase or decrease. Down here, I have another function, number 2 here. So in number 2, I have another function. It is x squared plus 4x. Remember what that's called? That's a quadratic, so it's a little different. G of x, f of x, that doesn't matter. It is equal to x squared plus 4x. And then the question is, what is g of negative 1? So what is g of negative 1? You take that negative 1 and you plug it in here. Negative 1 squared plus 4 times negative 1. Wherever there's an x, it is now a negative 1. So g of negative 1 is equal to negative 1 squared 1 plus negative 4, which is negative 3. So that's how you evaluate functions. Here's one more. This is actually similar to the one I just spoke of. Now your independent variable is t plus 2. Plug it in there to get 5 times t plus 2 plus 8. 5t, you got to distribute here, 5t plus 10, 5t plus 10, and then 8. So my final answer is 5t plus 18. Okay, moving on to section 14.2. That first section was all about functions. Now we are specifically looking at a linear function. A linear function, by definition, is a straight line. It is usually in the mx plus b form. So you could write it as y equals mx plus b. And the m and the b stand for something. And here I am saying it is a function. M is the slope of the line, and b is the y-intercept. So if I have this first example right here, y equals 4x minus 2, I recognize the slope is equal to 4, and the y-intercept is negative 2. This 4 is always a fraction. It is always rise over run. It is going to be the change in my y values over the change in my x values. This is a coordinate. It is saying it crosses the y-axis at negative 2. Remember, this is y, this is x. So if it crosses at negative 2, the x value there is 0. So the coordinate is over 0, meaning I don't go over at all, up a negative 2. The way I graph these is I graph my y-intercept first. From there, I rise 4, run 1. So I rise 1, 2, 3, 4. Negative 2 plus 4 is 2. And I go over 1. That gives me a second coordinate. It is a linear function. Any 2 points determine a line. I say arrows on each end to say it is infinite. There is no domain or range on that. And this graph right here, I could pick any point like a 2, plug it into my graph. 2 times 4, 8. 8 minus 2 is 6. And I could see that at 2, the corresponding y value is 6. Okay, let's take a look at another one here. Go ahead and graph this. Pause the video before you graph it. Before I graph it. Drawing out my Cartesian coordinate, labeling x with an arrow, vertical line y. I have a y-intercept of 5. Again, this is a fraction, it's a slope. M is equal to negative 2 over 1. So I rise negative 2, so I go down negative 2, I go over 1. So it starts at a 5, rises 2, runs 1, rises 2, runs 1, rises 2, runs 1. It is infinite in both directions with arrows on there. A negative slope means it leans this way. I think like as I sign my name in cursive, it is always positive slope. Going backwards that way will always be a negative slope. Again, like for this class to be successful, you got to pause the video a fair bit, take some notes, maybe rewind, rewatch some parts, and make sure it makes sense to you. Okay, section 14.3, still on linear functions, but we're setting up a table of values. So instead of graphing it as y equals mx plus b, you can also graph it, especially things you don't know how to graph. Maybe it's not linear, with a t-bar or a table of values. Again, x always comes first, and then y. I always pick a 0 in here, and I plug that into my function. 3 times 0, 0. 0 minus 2, negative 2. Pick a positive value. 3 minus 2, 2. 6 minus 2. I'll even pick a negative value. Negative 1 times 3, negative 3 minus 2, negative 5. And I can see there's a pattern here. As I increase by 1, by 1, by 1, I increase by 3, by 3, by 3. And that's why my slope is 3. However, I don't know where I start, so I need that value there to give me my y-intercept. It is over 0, up negative 2. From there, I rise 3, run 1. That's the way we did it before. Or I could just pick points. Here's my point 1, 1, right? Or if I rose 3 and ran 1. Those are my 2 points. 2 points determine a line. This idea of a t-bar is really important, especially when you don't recognize the function at all, if, say, it's not linear. Okay, example number 2. Again, pause the video. Give that table of values. Unpause, and this is what it looks like. I'm pick a 0. 1. 1. Negative 2 plus 1 is negative 1. 2. Negative 4 plus 1 is negative 3. So what's happening here is as I go up in x, y is going down. Therefore, it is a negative slope. That kind of makes sense. Negative 1, negative times the negative is positive. 2 plus 1 is 3. So every value I go up with 1, I go down by 2. This is going to give me my y-intercept over 0, up 1. Let's say I go over 1, up negative 1. There's my second point. Connect my dots. There's my line. Negative slope, which I expected. And I could say this is my y-intercept. I start at 1, and I go down to over 1. 2 different ways to do the same thing. Okay, 14.4, graphing functions in the slope-intercept form. So this equation, y equals mx plus b, is the slope-intercept form. Again, because m is your slope, b is your y-intercept. So how do you graph this one? Negative 3x plus 2. It has a y-intercept of 2. It has a negative slope, negative 3 over 1. I rise negative 3. Whoops. And I run 1. There's my second point. There's my graph right there. So that's the easiest one we've kind of run through. However, let's say they don't really give you those pieces and you have to find the slope. So to find the slope m, right, our equation y equals mx plus b, where m is slope, m can be defined as the change in y values, the difference in the rise over the change in x values. So if I have a line going through this point and this point, and I want to figure out the slope, it doesn't matter which point you call first, but once you call this the first point and the second, this has to be x1, y1. This has to be x2, y2. This is the y value of the second point. This is the x value of the second point. So what is the slope here? It is a difference in the y values, 9 minus 3, over the difference in the x values, 4 minus 1. That gives me 6 over 3. That reduces to 2. Now that I have that slope m, I could take it, plug it back into the equation, and solve if I have a point. The second way I could do it as well is I could use the equation of the slope-intercept form or point-slope form. Okay, so that's another equation. I don't think we're going to just go over that just yet. Let's take a look at this problem and see if we can figure it out. Given slope and intercept, this is a pretty easy problem here. Y equals mx plus b, where m is equal to 2. And y-intercept is negative 3. So I have y equals 2x minus 3. Let's do this problem number 2. This is not as easy. The way I would do this is I need a road map. I need to know where I'm going. So I'm going to do it this way. Actually, let's not look at this right here. So I'm going to go y equals mx plus b. That's my road map, my general equation. Well, it's telling you m is equal to 3. Take that value and plug it in there. Y is equal to 3x plus b. I don't know what b is, so I have to solve for that. But I have a value of x and y. When x is 2, y is 5. I have an ordered pair. So when x is 2, y is 5. Now I have one equation, one variable I could solve. So I have 5 is equal to 3 times 2 plus b. 5 is equal to 6 plus b. b is equal to, subtract 6 from both sides, negative 1. I have value for m, value for b. From my general equation, I can have a specific equation. Y equals m. Well, what is m? 3x plus b. What is b? Negative 1. So you could find the equation of a line given a slope and a point. We could do that here too. Now I only have 2 points, but I'm going to do it the same way. So again, I need a road map. Y equals mx plus b. Remember we had that equation for m. M is rise over run. Y2, the change in y values, over the change in x values. I'm going to call this point 2, so this is y2. 8 minus 4 over 3 minus 1 is equal to 4 over 2, or 2. From my general equation, I now have a slope. So from here, I have y equals 2x plus b. I need to find that b value. To do that, I got to pick a point. Well, actually, I have 2 points. You could pick either one. It doesn't really matter. I think I'm going to pick that one. When y is 4, x is 1, what is b? One equation, one variable. Solving for b, I get b is equal to 2. I have value for m, value for b. From my general equation, my road map, I go to my specific equation, y equals m, x plus b. A lot of stuff here, but if you're still with me, you're doing great. Let's go ahead and do some of these right here. Again, you want to pause the video, do this whole test, unpause the video, watch how I do it. Okay? So test chapter 14, linear functions. First thing we're doing is evaluating a function. Here is my function, 4x plus 7. Find f of 3. Take that 3, plug it in. 4 times 3, 12. 12 plus 7, 19. Here's a function, a quadratic function, x squared minus 2x. Find g of negative 2. So I have negative 2 squared minus 2 times negative 2. 4, right? Negative 2 times itself, negative 2. 4, and this is 4. This one's equal to 8. Number 3, graph that function using a table of values. So I'm going to set up a t-bar here of x and y. This is number 3. I'm a little crowded here. 0, that's where I always start. 0 times 3 is 0. 0 plus 1. 1 is 4. 2, 6 plus 1 is 7. Pick a negative value as well. Negative 3 plus 1, negative 2. Make sure this looks right. Plus 1, plus 1, plus 1, plus 3, plus 3, plus 3. I have some values. I could graph them out. Over 0, up 1. Remember, this is my y, this is my x. Over 1, up 4. 2 points determine a line. I could just stop right there and then graph that line. Okay, let me clear that board. I'm on number 4 now. Graph this using the idea that y is equal to mx plus b. So on that one, this is my b value 4. From 4, I rise, this is a fraction. I rise negative 2, come down 2, run 1. I'm at the point 0, 4. I come down 2 over 1, 2 points determine a line. I could check that by picking another point, plugging it back in, picking a point on my line, plugging it back in, and making sure it works. All right, number 5. If you're still here, good job. On 5, I have 2 points. So I'm going to find the slope of those points first. M is equal to 12 minus 6 over 5 minus 2. M is equal to 2. My general equation, y equals mx plus b. I have that value for m. I'm going to plug it in. Y is equal to 2x plus b. Then I need a point to solve for b. And it doesn't really matter which point I pick. I'm just going to pick this one. Always x, always y. Always x before y. 6 is equal to 2 times 2 plus b. So 6 is equal to 4 plus b. Subtract 4 from both sides. B is equal to 2. Well, that's the same as the previous one, maybe. Worked out the same. From my general, I go to my specific. Y equals mx plus b. Okay, number 6. This one's actually a little bit easier. Find the equation in a line with a slope of 4 and a y-intercept of negative 5. Y equals mx plus b. Was telling you what m is. Y is equal to 4x plus b. Well, b is negative 5. That's the equation of my line. It doesn't say graph it. If I needed to graph it, I would start at negative 5, rise 4, run 1, and it would look like that. And then this problem, similar to that, I have the key below. Make sure you do that problem as well. Kind of key takeaways from this chapter on functions is a relationship between x and y. Y is always your vertical axis, x your horizontal axis. Y depends on x, your independent variable. Once I've drawn my function, I could do a vertical line. If it crosses in one place, I can say it is a function, and then I could replace my y with f of x. Really what I am doing here is I am creating models or functions that can model certain behavior, whether it's economic or scientific. And then I take that model and I plug in values of x to get my outputs y. We've just kind of looked at linear functions, a few different ways to graph them. The standard is y equals mx plus b, where m is slope, b is the y-intercept. You don't know how to graph it, just set up a table of values, plug them in, connect the dots, and there's your map. And then the other way to solve it, if I'm given points, is I know the equation for m is a difference in the y over the difference in the x's. And then b, y-intercept, is where they cross the y-axis, where it crosses the y-axis. All right, well, I hope that was helpful. Again, we are covering a ton of material and not very much time. You know, usually in school, not only do you spend months of this in an algebra class, but you really start building it years and years before that, right? All of this starts by working on that number line, X, and bouncing all over the place. And then once you got numbers and you're drawing on here, you integrate in the vertical axis, and you're looking at ordered pairs. And then you have multiple ordered pairs creating lines. There's a ton of information here. I don't think this course could really fill in all of it, but hopefully you have been through a lot of it and it's just not all connected. And this course is kind of helping connect the dots like that. I appreciate you watching. If you're still here, you're doing great work, and this is going to bring up your test score. So thank you.